Hello everyone, welcome to this Python video lab submission. We are going to dive into an interesting problem solving exercise today with Python. I hope you enjoy the video. Now, our agenda for this presentation is as follows. Firstly, we will start by understanding the problem statement. We will mention the assumptions and also we will present some test cases. Then we will delve into the solution approaches. There are two approaches that we have looked into. One is the brute force approach, which is the less optimized version, and the other is the optimized approach. Now, in both the approaches, we'll try to delve into the pseudocode or the logic behind these approaches. Then we will also look at their time complexity and limitations, if any. Finally, we will look at the Python implementation of the optimized approach. Now let's try to understand the problem statement. Now we need to write a program to find two elements in a list of positive and negative integers that sum up closest to zero. The input list may not be sorted and may contain duplicate elements. We have a few assumptions like there could be more than one pair whose sum is same and closest to zero. We return any one pair in such cases. Another assumption is the maximum possible sum of any two elements in the list is 10 to the power 9. Also, if the provided list has less than two elements, the program should output an appropriate message. Now we have a few test cases here. The first two test cases, uh, they contain a list of uh, five integers and a list of eight integers with positive and negative integers in them. And the third one is basically the edge case where an empty list is passed to the program. So the output should be appropriate message that clearly identifies that the input list should contain at least two elements. Now let's take a look at our first approach, which is the brute force approach. Now first, we will check if the list has less than two elements. So we will check for the edge case. If it does, an error message will be thrown. Next, we will take a variable called minsum and we'll assign it to a very large value, in our case 10 to the power 9. We'll also initialize a tuple, an empty tuple called minpair, which will finally hold the pair of integers as our final output. Now, what we will do is we will iterate over each pair of the elements in the list using two nested loops. The first loop, where the index is I, it will run from the start to the end of the list. And within that loop, the index j will run from the I plus 1th element to the end of the list. Now, then this will ensure that each and every unique pair in the given list is checked. Now, for each pair in each of the step in each loop in the step 3, we will calculate the sum of both the ith and the jth element, and we will check its absolute value. If the absolute sum is less than the value of minsum, then we will update minsum with this particular sum, and also we will assign the tuple minpair with this pair of integers at that particular point. Now, when the loop completely runs, then the min pair will be the pair of elements that have the sum closest to zero. Now, in this case, we have used the data structure as a list for storing the integers and tuple for returning the pair of elements. The edge cases, as we have previously mentioned, is handled by the point number 1, where if the list has less than two elements, then an error message is passed on. Now, let's talk about the time complexity. The time complexity of this particular case is of the order n square, which what this means is if the size of the list is doubled, then the time it takes for the program to find the pair increases by 4 times. So there is a quadratic time complexity associated with this. Now, it is very evident why this method is inefficient for large lists where the quadratic time complexity becomes very, very high. Now let's look at the optimized approach. We begin with the same check for the list size, and if the list has fewer than 2 elements, we return an error message. We then sort the input list in ascending order and uh, initialize our pointers left and right to the start and the end of the list respectively. Now, additionally, we also initialize the variable min sum to a very large value, in our case 10 to the power 9, and we initialize a tuple to hold the integer pair called min pair. The tuple is called min pair, and we keep it empty. We then enter a loop that runs while the left element is less than the right. I'm sorry, it's not the left element. The left index is less than the right. In each iteration, we calculate the sum of the elements pointed by the left and right check and the absolute value of this sum. If the absolute sum is less than the absolute min sum, we update the min sum and the min pair accordingly. Depending on whether the sum is less than or equal to 0, we increment the left or decrement the right respectively. This process continues until the left and right cross each other. At the end of the loop, the min pair will hold the pair of elements that have the sum closest to 0. This method also uses a list and a tuple for storing data. Now, on the matter of the edge cases, it has the same edge cases as before as the previous approach, because the problem statement is the same. Now, in terms of time complexity, this approach has a complexity of the order n log n. Now, the term n log n may be a bit abstract, but it's a common time complexity for algorithms that divide their inputs in half or in some other fraction at each step. This is usually seen in sorting algorithms like merge sort or heap sort. In summary, compared to the brute force, the optimized approach is more efficient, especially for larger lists due to its lower time complexity. Now let's look at the Python implementation. Here, if you see, we first check for the edge case, whether the length of the list is less than 2, and then the message is returned. Input list should contain at least 2 elements. Then we sort the list and we assign left equal to 0 and right equal to the last element of the list, which is the length of the list minus 1. Now we initialize the min sum to is equal to 10 to the power 9, and we define an empty tuple. While the left is less than right, we assign the sum we assign sum equal to the left element of the tuple plus the right element of the tuple. Now, we check if the absolute sum, which is calculated above, is less than the absolute minimum sum, which will always be the case when the loop runs for the first time, and hence the min sum will be assigned the sum calculated in the first step. Now we assign min sum equal to sum. Now then we assign the pair to the left and the right indexes, whichever elements are the left and the right indexes at the moment, at that point of time. Now, if the sum is less than 0, then we increment left by 1, or if the sum is greater than 0, we increment, if the sum is greater than equal to 0, then we reduce the right index by 1. Finally, when the right index becomes lesser than the value of the left index, the left index, then the loop will exit and we will return the pair. As you can see, the test cases are giving the right results as expected, and there I rest my case. Thank you so much.